Hello everyone, my name is TCherry Jr. and this is my final project presentation for database applications. Over the last few weeks I have designed and implemented a relational database aimed at solving a very specific real-world business problem, the digital marketing campaign performance database. Today I'm going to walk you through the concept, the design, architecture, and the actual implementation of this system. Let's get started. In the modern marketing landscape, data is everything, but for many agencies, that data is a mess. The core challenge I addressed is fragmentation. A typical agency runs ads on Google, Facebook, Instagram, and email platforms simultaneously. The problem, these platforms don't talk to each other. Disconnected sources, you have spending data in one tab and conversion data in another. You have inconsistent reporting where Google might call it a conversion while Facebook calls it a goal. Your ROI uncertainty because of this, calculating a true return on investment becomes a nightmare because of manual spreadsheets. This inefficiency isn't just annoying, it costs money and wastes valuable strategic time. The solution and focus of this project is a centralized relational database. Instead of relying on 5 different dashboards, we ingest that data into a single unified architecture. By normalizing this data, we move away from guessing and toward actionable insights. This database allows a marketer to query across all channels simultaneously to see exactly where their budget is going and what they are getting in return instantly. My mission for this database design was driven by 3 specific objectives: standardized data, empowering decisions, and driving value. I wanted to create a consistent structure. Whether an ad comes from TikTok or Google, in my database, it looks the same. I wanted to give users the ability to identify opportunities for smarter budget allocation in real time, and ultimately, the goal is to reduce the human error associated with manual reporting. If we can trust the data, we can trust our decisions. Now, let's look at the architecture. I designed this using a variation of star schema, which is optimized for analytics. We have our central fact table, which implies the performance metrics, surrounded by our dimensions and campaigns, which hold our budget objectives, our channels, which are the platforms that we use, our audience and creatives, the who and the what, and the dimensions, such as date and client information. This structure allows us to slice and dice the data. We look at performance day by day, by creative image, or by client without changing the underlying structure. Here is how those entities actually relate to one another. Designing the entity relationship diagram, or the ERD, was critical to ensuring data integrity. We utilize specific logical connections. One-to-many, for example, a single client pays for multiple campaigns. A single campaign generates many daily performance records. And many-to-many is as this connects our audience and creatives together. A specific target audience might see 5 different ad creatives, and one ad creative might be shown to 5 different audiences. By strictly defining these relationships using foreign keys, we ensure that you can't have a performance metric that doesn't belong to a valid campaign. I want to zoom in on the engine of this database, the performance the fact performance daily table. This is a transactional table. Every single day, for every active ad, a row is created here. The fact ID is our primary key, a unique identifier for every record. Then you have your foreign keys, like your date ID, your campaign ID, where these link us back to the dimensions I mentioned earlier. Impressions, the metrics behind everything would be the impressions, spend, and conversions. By keeping this table at the daily level of granularity, we maintain the highest level of flexibility for reporting over time. A database is only as good as the quality of the data inside it. To protect that quality, I implemented strict business rules. The database rejects orphan data, also known as referential integrity. You cannot enter spend, quote unquote, for a campaign that doesn't exist. With data validation, I set constraints to measure metrics like clicks or spend are non-negative. You can't spend negative dollars. And then logistical consistency. We ensure that a campaign's start date is always before its end date. These rules are enforced at the database level, not just the application level, providing a strong safety net. To bring this design to life, I utilize a standard robust tech stack with XAMPP. I used XAMPP for my local development environment to host the Apache server, Maria and the MySQL. This was the core RDBMS used for the actual storage and SQL processing. With phpMyAdmin, I utilized this for visual verification and initial table creation. For the actual SQL implementation, I utilized a hybrid approach. While phpMyAdmin provided a great graphical user interface for quickly verifying that my foreign keys were linking correctly, I spent a significant amount of time in the terminal. And in conclusion, this project was about moving from chaos to clarity. By taking fragmented marketing data and forcing it into a structured relational data scheme, we have ensured data integrity and set the stage for automated reporting. This database transforms raw numbers into a strategic asset that can genuinely grow a business. Thank you.